Right, so this is the check your understanding for topics 8.9 and 8.10, which is volume using the disk method. So that's where we take a curve, we're going to spin it around the x or y axis or some other line, and then figure out what's going on. So let's see what's going on. All right, let R be the region bounded by y equals square root of x, the x-axis, and the vertical lines x equals 0 and x equals 4. So the square root function, which is just the parabola, x is 4. It's a sideways parabola, of course. X is 4. We're going to chop it off there. X is 0. We're rotating around the x-axis. So when I was a kid, I used to always draw them. I'm really bad at drawing the shape, but the idea would be that this would become kind of this circular shape like so. Okay, after we spun it. So we're going to be getting whole circles. And so we're going to have the integral from 0 to 4 of the square root of x, radius. This is r. So r equals the square root of x minus 0. So square root of x squared dx, and then pi goes out here. Pi r squared dx. Okay, take a minute, see what you think. If you disagree, let me. Okay, I think I did a good job, so I'm going to keep going. Pi integral from 0 to 4 of x dx, which is equal to pi x squared evaluated from 0 to 4. And so pi times 16 minus pi times 0 is 16 pi units cubed. Sounds good. Okay, let R be the region generated by y equals x squared, x equals 0, and y equals 4. This is very much the same kind of problem, except for now it's going this way. We're going to be rotating around the y-axis, and so that means I'm going to end up with the same basic shape, just going this way. It's terrible. So I don't do this very often. Okay. And so I need to take this and solve it for y, because r is a horizontal slice, which means I need y alone, or x alone. And since I'm bounded here, I only need the principal square root. I'm going to be going from 0 to 4. Pi square root of y squared dy. Okay, take a look. See what you think. So as I was thinking, I looked back at this one because I'm like, oh, they're going to be the same. And they're not. I apologize for that. I mean, they are the same, but I got this one wrong. When I did the antiderivative here, I forgot to divide by 2. So my answer is actually 8 pi. Okay. Let's take the antiderivative. We're going to get 4. Pi 0 to 4 y dy, which will be pi times y to the second divided by 2, because this time I won't forget, evaluated from 0 to 4, which will be pi times 16 over 2 minus pi times 0 over 2 equals 8 pi units cubed. So they're the same, and they should be. The only reason these should be different is if I went different place, or rotate it around a different line. It's very important to be careful about the lines. I was not tricky on any of these, just so you're aware. This one again was a little tricky. Let R be the region in the first quadrant bounded by the curves y equals ln x and y equals 5 minus x. And the x-axis is shown below. So we've used this actual shape a couple of times recently when we're talking about finding the area of the region. But now we're going to find what happens when I rotate this around the x-axis. Okay, and so we actually need to do 2. I'm going to get this shape as a circle. It's going to be circular. So we're going to have a cone on that part. Anyway, okay, so that's the idea. All right. So I'm going to have the integral. I need to remember where they meet because that's where it's going to take over. Okay. I'm going to have 2 integrals. We're going to call this a comma b. Right? We'll find it in a minute. We're going to use a calculator for this. We're going to go from 1 to a of ln x squared dx, and pi's out front, plus pi, the integral from a to 1, 2, 3, 4, 5 of 5 minus x dx. So that's what we're going to do. We just need to figure out what a is. So calculator time. And they're still there from last time I did this. So what I want to show you today is how to store. And I'm really bad at this, so hopefully it works. So I never do it. I just write down the numbers. So go ahead and look at the graph. We're looking for where they intersect. So that's math trace. No, excuse me. No. Graph. Alpha trace. No. Second trace. Number 5. So what's wrong with me? First curve is the blue one. Then the second curve is the red one. And I think they meet close to 4. And so there's my intersection. And so what I'm going to do is I'm going to click this STO button. And I'm going to click see, I can't do it. I never do it. Okay, write down. A comma B is A equals 3.693414, and B is 1.30655586. Okay. And there's a way to do this, and if somebody can help me with storing, that'd be awesome. I've looked it up. I can't ever do it right. I don't know what to push. So store. No. I don't know. I just don't know how to do it. Sorry. Anyway, we have that. So let's go ahead and go and let our calculator do the rest of the work for us anyway. Second. Quit. We're going to do math 9, our favorite new thing, from 1 to 9 to A. And A is this number, 0.693441. Of ln x parentheses, squared dx times pi, which is 6.4105593. Okay, we're going to do it again, math 9. And we're going to go from 3.6934414. If you can figure out store, it's better to use the store. You can never do it right. To 5 of, oh wait, that's supposed to be squared. Square that. My writing. 5 minus x whole squared dx and times pi. 2.3356905512. And the other thing I can do, I'm going to do this on the calculator now, is pi times that plus pi, and just let the calculator handle it for me all the way through. And I got 6 plus 2 would be 8. 4 plus 3 would be 7. You can see that's the answer I'm getting. 8.746. 3 decimal places. Notice I did not round until I put 3 decimals down until I got here. Okay, there you go. We will practice this more. We will not be moving on until we feel at least a little bit more comfortable. Have a great day.